But now we're going to hear about open source Python-based tools for data privacy by Cillian Kieran.
Thank you so much, Mason. Thank you all for having me. I'm conscious I'm going to try and get through a huge amount in 30 minutes, so I apologize if I speak very, very quickly. All of the documentation, all of the repos I'm going to use for this are publicly available, and there are links to everything. So if you're trying to furiously keep up, please don't. Try and just listen, I guess. So very quickly, I'm Cillian Kieran. I'm the founder and CEO of Ethica. We're a data privacy engineering company. I'll explain what that is in a moment more substantively. I'm here specifically to talk to you about a handful of things that we do. So very quickly, we have this sort of thesis about privacy we call privacy as code. I'm going to explain what that is very quickly. Then an overview of FIDES, so what that is, and then show you examples of privacy as code using FIDES, which is an open source privacy engineering platform. So it really is information dense. I apologize in advance. I wanted to squeeze as much in for you guys as possible. This might seem obvious, but at Ethica, we're about 35 or 40 people, and we believe privacy is a fundamental human right. Everybody in this audience is probably going to agree to that. Privacy is a fundamental human right. But it turns out it's really, really complicated, particularly for engineers, right? Like, it's a difficult thing to do well. So we care about it, but it's difficult. Privacy today in most businesses, not everyone's, but most businesses, sort of happens after you ship software, right? So you ship an application, and then you have to address privacy problems because you've collected some data, right, in production. You've got human beings' information in it. Now you've got a privacy risk. And it becomes a pain for developers and for lawyers. Often it's a pain for developers from lawyers, right? Like, that's the reality of it. And it's things like you might have heard of, like data discovery, data annotation, data mapping, privacy reviews, risk reviews, consent, rights propagation, et cetera. All of these sort of complicated legal concepts. Now, the cause of a lot of this are reasonably new or relatively new legal regulations, like the GDPR in Europe, the CCPA or the CPRA in California, the LGPD in Brazil, the People Act in China. There are many, many privacy regulations, right? You're not expected to know the acronyms. You're engineers, that's the point. The idea behind a lot of these, though, is privacy by design. Now, if you're not familiar with privacy by design, that's an entirely different topic that we won't have time to cover today. There are 7 principles in privacy by design, but the TLDR is essentially how do you make privacy a design consideration in technical implementation? Like, so how do you do it sooner? How do you make sure that you don't ship a product having not thought about privacy? These are some of the acronyms and sort of definitions that exist in the world of privacy, right? They're pretty complicated. Anyone here know what a DPIA is? You don't have to answer, but like they're examples, right? That's a data protection impact assessment. What it really means in plain English is a privacy review. Evaluate the risk of the code that we're writing to make sure that we don't compromise the human rights of the individual's data in the system, right? So lots of these complex concepts for engineers. And what we think at Ethica essentially is that tools should be built to add privacy into software development. A bit like shift left for security, right? Like, not so different. And we call that privacy as code. It's this idea that we can provide tools to developers to make it easier to build safer, more respectful systems. And the benefit of this is really obvious, right? If you could accomplish this, like future state panacea, right? You'd essentially not have to think so much about privacy, not because you as developers don't care about it, but you're busy doing other things, right? Like, you're trying to ship applications, solve problems. Privacy is sort of a means to an end. It's a non-functional requirement almost, right? And so we think of it as a layer of our tech stack, right? We've got front end, back end, data infrastructure, infrastructure as code, our source control environments. We should have a layer that deals with privacy. So that brings us to the project that we've been working on at Ethica for over 3 years. So the company's about 3 years old. And we've been working on this project we call FIDES. FIDES is named after the Roman goddess of trust. We think that's apt, given all things. And it does what it says, right? It's an open source developer tool for privacy by design, right? In any tech stack. Now, it happens to be built in Python, and that's why we're here. Everything we do is built in Python. And the intention of this is to help developers and engineers of all kinds, right? Software, product, data engineers, to more easily comply with regulations. So sort of remove the cognitive load so you don't have to think about these issues and ensure that you're building safe systems for everybody, right? So this is a very, very dense slide. We'll try and explain it very simply. The left side, you've got code management environments, right? The sort of software development lifecycle where we design, implement, test, and eventually ship stuff. On the right side, you've got your runtime environments, right? Your sort of production infrastructure. The types of questions that the laws ask us to answer are things like, on the left, well, how can we prevent risk when we're building our products, right? Like, how do we prevent ourselves from accidentally using phone numbers that were collected for security and exposing them in APIs for developers for games? That's a real example, right? That's why Facebook got fined $5 billion for doing that. Meta, I guess. runtime, production environment, questions like how do we dynamically define and enforce a user's rights? Now, what do we mean here, right? The GDPR and the CPRA and the LGPD, they provide human beings, all of us in the room and everybody, with rights. Like I can be deleted from a system, and developers need to be able to assure that we can guarantee that we can consistently delete someone from an entire distributed data infrastructure, and that could be petabytes, right? So code management environment is how do we prevent risk? Runtime is how do we ensure we afford a user or a human their rights? So we have tools in Fidesz that solve these problems. Fidesz control is on the left, and we'll talk about that in a moment, and Fidesz ops is on the right for the runtime. So the way to think about Fidesz, and I know I'm going fast, but I'm trying to cover a lot of ground. I haven't even got to the live demo where I fall flat on my face. The core of Fidesz is the language, Fidesz lang, and I'll show you that in a moment. Think of it as a lightweight description language for privacy, and I'll sort of elaborate on what that means in a second. And again, we've got two applications or tools that sit on top of the language. Fidesz control, which I mentioned, is a server that runs in the software development lifecycle effectively. It does a few other nifty things, but think of it that way. And Fidesz ops is a containerized application that allows you to execute and manage tasks on behalf of users' rights. Okay. So a little bit more about the language. This is very hard to see on screen. So if you are sitting at a computer, I'd encourage you to, let me get rid of that. I'd encourage you to go to fid.es/taxonomy, and you can explore the taxonomy in the open source docs directly. But so it's a description language. When we say description, we mean lightweight in the way that Terraform is, right? So Terraform describes infrastructure, Fidesz describes privacy characteristics. So its intention is to ensure that an engineer or developer doesn't need to know a whole lot about privacy. You can describe the personal data or behaviors of your system's data such that you can then enforce policy or mitigate risk, right? So we don't need to know about privacy, we just need to be able to describe what our system is doing, and Fidesz takes care of the rest. So let's talk about the sort of four components of the core taxonomy in a little bit more detail. They're what we call data categories, right? So they're the what, like the what type of data am I processing? So is it email addresses, is it behavioral information? What kind of information am I dealing with? Then you've got data subjects, right? That's the who. So who owns the information? Now, ownership is a sort of tricky concept in privacy, right? Because an owner in this context is from whom the data came, right? So an individual, like Mason, for example, right? Whereas an owner could also be somebody that has collected and has a legal right of ownership. Here we're talking about the human being behind the information, though, right? Then you got data uses. So think of that like what we're using the information for. Are we personalizing our system? Are we doing advertising? What are we doing with that data? And then finally, data qualifiers. So think of a qualifier in Fidesz as a way of declaring how identifiable an individual is in a given data set. So someone might be fully identified, right? That is to say you've got fully identifiable data. You might have partially pseudonymized or pseudonymized and unlinked data. You might have aggregated and partially anonymized data. And all of these create a different risk of re-identification in a data set. Now, what's important to understand is with these four sort of very simple concepts, data categories, data subjects, data uses, and data qualifiers, you can essentially model most of the, let's call it, data and privacy characteristics of a system. And that's the purpose of this, right? Do it very, very simply. So again, if you want to explore the taxonomy a bit more, you can do that online. The one thing I would note is it ships with the taxonomy that we've built over the last 3 years, working with standards for the GDPR, the CPRA, LGPD, also ISO 19944, which is the ISO standard related to cloud service provider data flows, essentially. So it models against all of the complex regulations that you'd need to consider if you're thinking about privacy. You can extend it. So most of the business users that use our open source tools have extended it for their specific uses, and we can talk about that afterwards. So then we get into how you actually declare, like how you write this stuff. It's pretty simple. Like I mentioned, it's intentionally lightweight and declarative in style, right? It's dot notation mostly. You'll see there's some snake case in there in some places, which is not ideal. We're working on it. You declare it as YAMLs in your projects. We're currently working on a version that allows you to declare it inline in whatever language you're working. Obviously, first for us is Python, then Java and Scala. But so effectively today, you declare it in distinct YAML files that you check into your projects. So if I wanted to describe two types of data I was handling, just as examples, if I wanted to say I was dealing with data that's non-personal, right? It's data related to systems operations, like a timestamp, I would simply declare it in that way, system.operations, right? If I wanted to declare that I was dealing with an email address, I would say to user-provided, identifiable, contact email. Now, I can be very specific, so very fine-grained, a specific sort of label, like an email address, or I can be very abstract. If I, as a developer, don't really know what I'm dealing with, it might be just, I know it's user data, I could just declare it as user data. So just very conceptually, it's very simple. Then we get into Fides primitives, right? So there are sort of 4 primitive resources that exist in Fides. There are organizations. They're pretty obvious, right? So it represents all or part or any of an organization, right? So it could be a company like Acme Inc., or it could be a department in a company. It establishes the root of the resource hierarchy. So what we mean by that is they have limited scope. So if you had 2 resources within one project, or 2 organizations within one project, for example, one organization cannot seek out the scope of another, right? They are completely distinct. There's no way around that by design. Then you've got systems. So systems represent the privacy properties of a single project or a service or some code base or an application. So think of that as describing the behavior of my system. Again, think of that could be a single service, could be an entire monolithic application. It depends on how coarsely or how narrowly you want to describe a system's behaviors or properties. So we see a lot of use of this with larger sort of enterprise customer users of the open source tools, and they're describing individual services, right? Like right down to a single microservice. And so it describes the category of data you're using and the purpose for which you're using it. And then you've got data sets. Now, in most cases, data sets, you can think of them as really describing a sort of data source, like a database or data warehouse or some other storage system. More practically, data sets in Fides are designed to represent or model anything that might contain data. So a list, a collection, an interface, etc. And finally, you've got policies. So think of policies exactly as they sound, the ability to describe a set of rules about your system in code. So it's like taking the privacy policy of a business and converting it into an enforceable rule on that system. And I'll show you an example of that in a minute. And we do that by evaluating policies against systems and organizational data sets. Okay? So what can you do with Fides? You can do a whole bunch of things, but the ones that we're going to focus on today, you can effectively declare what type of data you're handling in your application. You can describe how your system is using that data. And then you can declare what kind of policies you want to enforce, right? So I don't want to be able to do these things, or I permit these things, for example. There's a bunch of other nifty things. So again, just a reminder, it's Fides Control, which is the developer tools for shifting privacy left, so making it easier for developers to do this. And then there's Fides Ops, which is that runtime application that allows us to execute tasks on our systems. I'm going to try and show you an example of both. How are we doing for time? We're good? Okay, awesome. So we've got 2 use cases. So the first is policy enforcement in development, okay? Now, here's a really frightening, well, I'll get to that very frightening slide in a minute. Let's just explain Fides Control's configuration and components for a moment. It's very simple. You could deploy it in about 10 minutes. If you grab the Fides demo repo and just run make demo, it'll be up and running and you can play with it. But there's essentially a Fides Control server backed to, in this case, a Postgres database. And there are integrations to your CI pipelines. And there's also a CLI tool, so you can query it directly. So it's, at the moment, the web server is essentially headless. There's some basic UIs for reporting, which I'll show you in a moment. But the server essentially maintains the metadata that's checked in and out through the CI pipeline and evaluates policies, right? So it's a very simple architectural model. To get started, super simple. You can declare an toml file or a bunch of environment variables, straightforward. You can see here there's a URL for the database, server, etc. If you want to get it set up, as I mentioned, you can go to fidesfid.es/control, and the configuration documents, like quick start, is just /config. Okay. So there's a bunch of commands, and we won't have time to get through them all here, but I just want to draw your attention to 4 that are particularly interesting. They're listed here alphabetically, but I'm going to sort of reorganize them to explain them. So the first thing that you can do is actually scan data infrastructure. So you can actually point Fides Control at, for example, an AWS environment, and it will return a list of systems that may contain data and generate data set and system files for them. So you don't have to do that manually. You're not manually declaring everything. It will generate a scanned view of your systems. From there, you can generate a data set. So you can point it directly at a data source. You can credential it against, say, Postgres or Redshift, and it will generate a Fides dataset declaration file. You can then manually annotate it, right? So you can describe the types of information that are in that data set. I'm going to show you these in a moment. And then you can evaluate the risk. So you can say, hey, check this against policies for the organization. If you want to see a full list of the commands, it's just Fides/command. Now, onto the scary thing. I mentioned we're going to do a policy evaluation. Some of you may be familiar with this because you're in large organizations, some of you less so. This is what privacy laws are all about. This is not ours, this is the CNIL. So the CNIL is the French regulator, right? So if your software is deployed and being used by consumers in France, the French regulator is looking at it to make sure that you're doing these types of things. This thing I'm referring to is a protection impact assessment or a privacy review, if you're not familiar with these particular regulations. Privacy review basically seeks to create like a giant Rube Goldberg machine, right? tell us what type of data you're handling, what are you doing with that data, for what purpose, with who, and by who the user's data. What kind of risk does it create? Is there a risk of compromising the user's rights or a security risk? Evaluate that risk, mitigate it, and generate an audit trail. Like show us that you sort of thoughtfully considered the risks to your users, right? Sort of like what you would do in threat modeling for security, right? Like the same thing but for privacy. It's pretty complex. It usually involves legal specialists because they understand the privacy stuff, and engineers because they understand the engineering stuff, right? So what we wanted to do was make this easy, right? We wanted to provide tools that would allow us to describe or declare a policy, like a thing we want to support in a business or a team, and then to enforce that, so we don't have to check it constantly manually. So in this example, what we're going to do is we're going to declare the type of data we're processing and storing. We're going to talk about the type of system that we're doing that in, and we're going to check it against a fictional policy and enforce it, okay? And then we're going to maintain an audit trail, so we'll be able to see reports about that. So I'm just going to jump out of this document for a second, and I'm now going to attempt to do this live, and of course it'll probably break, but we'll have a go. So the first thing we're going to do is just to show you an example of the scan command running. Basically, this is our demo environment. You can spin these tools up yourself very quickly. I've declared some environment variables just to sort of hide URLs that were pointed at. And basically what I'm going to do here is I'm going to, first of all, let's see. Run the scanner first, yeah. So the first thing we're going to do here is we're just going to scan AWS infrastructure that I've credentialed this to, right? So it's basically using the Fides control server to connect to an AWS environment and scan it for resources. And by this we mean sort of anything that may contain data, and I put that to a YAML file. Ignore that. That's actually not an error. That's a known issue. Right, let me see if I can make this a little bit clearer. Okay, it's a bit information dense, but you'll see what it's returned here is a list of systems, right, with keys, essentially. If I expand one of these out, you can see here it describes it with a little bit of metadata, what kind of resource it is, and then some of the ARNs and addresses for this particular Redshift cluster in AWS. So it's generated this metadata view, right, essentially a metadata map at the very abstract level, each of the systems in our distributed infrastructure. So that's the first step. We've just identified systems that need to be understood, okay? The next thing we want to do is actually connect to one of those and generate a data set that we can actually label, okay? So we want to say, what kind of information are we handling in these systems? So we'll just do generate. So here you'll see at the top half, we've just got a YAML file that's empty that I'm just using as a destination for this, essentially. And here you'll see I'm basically using the generate dataset command against a database. There's a database URL declared. I'm just writing out to this YAML file. Now this will take a few seconds to run. It's actually going to query the DDL and return a data model for it. Hopefully. Uncomfortable silence, I know. There we go. Okay, phew. So you'll see here there are four simple databases here. If I look at one of these, I've got a set of metadata that describes the database itself, and then each of the tables that exist here. And if I expand those out, I can see there's a description about what it is, there's a data qualifier, and there's empty data categories. So I don't know what type of data is in here today, right? Like that's not declared, it's not modeled. I need to label this manually. So all we've done so far, just to be clear, is scanned for data systems, generated data sets. And the next thing we're going to do is talk about how we label these. Now, to make this a little bit more real, I'm running from that demo project that I mentioned, the Fides demo repo. I'm running this fictional e-commerce system that I'll show you very quickly. It's a thing of beauty. It has 3 products, a Postgres database, no images, but it's a very simple application. It's a Flask application. It allows us to test the sort of concepts of Fides. So in this case, we've got a couple of products, we've got some users, so it means that we have a very simple data model, right? If I go to the Postgres database for this system, you can see here it's got a products table, a purchases table, and a users table. And if I expand out the users table for a moment, you can see it essentially has 6 columns or 6 fields of information: a created at timestamp, email, first name, ID, last name, and password. Now we look at how these are annotated or declared in Fides, right? So if I look at the created at field, you can see it carries a data categories label as systems operations data. Right? It's the type of information it's in here. It's data related to system operations. If I compare this to email address, I've got user provided, so user provided identifiable contact email. Now as a developer, if I don't know the structure of this, bless you, I can simply declare it maybe as user data. I might just say it's user information. I could say it's user provided. I know that it's actually been provided by the user. It could have been derived about the user through observation. Is it then identifiable? Is it contact information? I could just leave it there. Or I could specify that it's email. Now, these are coming from the FIDES taxonomy, right? So these are specifically from this taxonomy, okay? So I'm declaring the type of information I'm handling in my data set. Now, the other side of this is the system. So it's the actual application that's processing information. So let's take a quick look at that. So we've got our data set declaration, we've got our system declaration. And we can see here that it describes a little bit about it. It's a sample e-commerce application. It's used for the purpose of simulating an e-commerce system. Now, if we expand our privacy declaration, we'll see that it says we provide e-commerce capabilities, and it declares the types of data we're handling. So in this case, we're handling user-provided identifiable data, user-derived identifiable data, and system operations data. And it's for the purpose, the data use is e-commerce, right? We're not advertising, we're not selling the data, we're not doing any behavioral analysis, any machine learning classification, we're just providing e-commerce capability. And we've got a custom subject type or user type called a Flask customer. That's all it is. Okay. So this declares the purpose of the system. The other declares the type of data we're handling. Now let's run an evaluation. So I'm not running a CI pipeline here, so I'm basically forcing an evaluation with the FIDES control server on my CLI. So we'll just run that very quickly. FIDES control evaluate. Now if you look carefully here, this is maybe a little hard to see. You'll see that what it's done is it's grabbed the system resources files, all of the data use and declarations, and it basically checks it against a policy. And it says that it's passed. We get all greens. Everything's good to go, okay? So code's checked in. Now let's imagine for a moment that I'm working away as a developer on this e-commerce application. I actually decide what we're handling here is not going to be an email address. It's actually users provided identifiable health and medical data, okay? So this email address is actually some kind of health and medical data. And now I attempt to check it in again. So it's checking against our policy, big red failure message. And if we look carefully here, the failure is caused by a rule about rejecting the use of sensitive data. So it's basically said, hey, we have a policy in this business that says we reject the use of sensitive data for any of these purposes, and you're attempting to do that. That's a big risk for us. We can't do that. So how is that actually being generated? Well, let's look at the policy file. So this policy file written in FIDES is very, very primitive. There's two rules. One is minimizing the use of identifiable data, and the other is rejecting the use of sensitive data. So let's look at the rejection one first. We can see here that it's a simple rejection policy, right? If any of these categories of data, any of these categories, any of these types, biometric, children's, genetic, political, race, religion, is being used for any of these purposes, right? For personalizing our system, for advertising, for third-party sharing, for training an AI system, we don't permit that. We reject that. That code cannot be committed in this organization. Now that sounds very harsh, but the effort here is to prevent us from prevent us from failing and then finding a risk in production, in addition to which it prevents the Rube Goldberg machine I mentioned, hours of paperwork with legal teams to review risk. So we check it in, we find that there's a failure, we update something in our code base, we redeclare our YAML file, and we're good to go, it gets checked in. And each of these policies is evaluated into an audit trail, right? So if I look here, we can see the audit trail. I've been running some fails and passes throughout the day just to test it. The most recent one here is this violation that relates to the use of health and medical data in our e-commerce system. So we generate an audit trail for these things. So let's go back to our document very quickly. So what we've done there is essentially declare the type of data we're handling, what our system is doing, and evaluate the risk related to policies we have in a business, and generate a report on it. Okay, very, very quick. I'm running out of time, so I'm going to go really, really fast through the last one, I promise. So the last use case is programmatic data rights. So sometimes called subject rights, DSRs, data subject rights requests, et cetera. This is the idea that we can say, hey, Google, delete me from your distributed systems. And in Europe, they've got 30 days to completely nuke you from those systems, right? No soft deletes. You've got to be gone. We can all imagine the engineering difficulty in achieving this. The first issue is you don't know where the data is. This is what data subject access requests look like in practice. They can be submitted by paper, email, a phone call. This is a real one that's been anonymized a little bit. So this is how they arrive in a company. And then usually what happens is they go into some kind of ticketing system. Someone in the legal team maybe reviews the risk, or customer support teams have been trained. Then they open up a ticket in Jira, and then that ticket is distributed to a bunch of engineers to try and go spelunking to find a user's data. The average time here in the US to complete a data subject request is 19 days, and it involves 10 people. So it's like a huge amount of effort, right? So what we've attempted to do with that metadata layer that you've just seen being generated by the control server is leverage that to build a map of where categories of information exist in the organization and then process them, right? So we can create a policy for enforcement, then we could retrieve or erase data from those systems without having to keep updating it, right? So we have like consistency between our CI pipeline and our production data model. So in this example, what we're going to do is we're going to retrieve some fictional data about our fictional user in this e-commerce system. We're going to look at what that looks like, and then we're going to run it again when we've made some changes to the data model. Okay. So back to VS Code. Actually, not back to VS Code. Let's go to our browser for a minute. So if you recall, we had our fictional e-commerce system. We've got a test user in here called example user, I think it is. Let me double check. Yeah, example user. Okay, so we've already got a test user in this system. So what I'm going to do is go to the privacy center. These are all part of the open source tools. So like there's a web application that sits on top of the Fides ops tools that you can style whatever way you want and allows you to receive and process privacy requests. So in this one, it's simply configured to take an email address. So I'm going to submit my email address. There's no validations. It's very simple. You can modify it whatever way you want. And that's submitted to the Fides ops server. And there's a UI that sits on top of that for managing those requests, so we don't have to do this manually. Now, it's all API driven. You could ignore the UIs if you wanted to. We built these to make it easier for non-technical users. So in this case, we'll see that hopefully when it reloads, we've got a new privacy request has been submitted. When we reveal the PII, we can see it's for our example user. And we're going to approve this request. And what's going to happen is it's going to go and retrieve from any of the connected systems that user's data based on the data categories in that policy. It's going to write it to a JSON file and dump it in this directory. And there it is. So what I'm going to do is just open it very quickly. We'll just try and prettyify it a bit. OK, there we go. So if you look carefully at what it's returned, just a blob of JSON, there's the purchase address used by the user. There's actually, on MailChimp, we found not only is it the user's email address, it's also storing the user's physical address in MailChimp. I'm not sure why, but it does. And some basic information about the user in that way. Now, from here, what would normally happen is we continue to through agile development in our software development lifecycle. We make changes, the data model adjusts, and then we've got to rewrite all of the scripts and tasks that are run to retrieve user data. Now, this is where Fides control and Fides ops play together. So, for example, if I go back to that Postgres data set I had, and let's make this, we'll return this to contact email. And let's say that systems operations data. We'll say, well, actually, this isn't systems operations data. We're going to say it's user data. Now, by doing that, we're declaring this personal information. So if a privacy request is run, now we would return that timestamp. Okay. So there's a watch engine running in the background here that's monitoring these. It's a cheat, so I can do this more quickly for you. So I'm going to resubmit that privacy request for this user. A new one come up now. There we go. There's a new one. I'm just going to approve this. And we'll see another JSON object get generated. And if I open this, we just compare it to our first one. What we'll see is now it's returning some additional data about the user that is identified as the timestamp information because that was identified as user information as metadata in the data model. So effectively, changes in our CI pipeline are now reflected directly in the metadata layer that's enforceable for our policies. So engineers don't have to rewrite anything that's spelunking in Postgres or Redshift, et cetera, to retrieve data. So what we've done there is construct a very simple policy, retrieve a user data, change the data model, and then reflect that in that production system. Some of the other things that we're working on, I'll jump forward, are basically about simplifying privacy. So we'll be releasing our machine learning classifier. I don't have time, but I was going to give you guys a sneak preview. We've been working on it for a year, and it automatically labels data sets with the Fides taxonomy. We're adding a UI for better visualization for non-technical users, and then a bunch of features that we're building over the next 3 years to help alleviate issues like access controls in production systems. So that's it, right? What is privacy as code? We've covered that. It's an easy way to manage privacy in the development lifecycle. You can do this with Fides, which is free. And I've shown you a couple of examples of how you can check a policy in CI and automate a data rights request. It's free and open source, all Python-based. You can get up and running in 15 minutes. I'd urge you to go and grab the project. Or you can join the Slack community and learn more about it. Thank you very much for your time. I really, really appreciate it.